Security course. In this course, we are using the Huawei HCIA cloud computing materials, and today we are going to take chapter number 6. Chapter 6 is on visualization. As you all know, visualization is a way of sharing physical hardware resources into different virtual devices that can be shared and can be used by different users. Visualization actually is the backbone or the foundation of cloud computing. Cloud computing depends solidly on visualization because cloud is a virtual environment by design. So visualization is very important in cloud computing, and we have to understand how visualization works for us to be able to use cloud computing environments effectively. So as I mentioned just now, visualization is the foundation of cloud. Cloud computing depends solidly on visualization technology. So what is the essence of visualization is one of the things we are going to look at. What are the mainstream visualization technologies? So all these will be answered in this chapter we are going to treat today. The objectives of the chapter. The first is to describe the essence and value of visualization, especially as it relates to cloud computing. And we hope that at the end of this chapter, the student will be able to understand some of the mainstream visualization technologies. So actually, we have used a lot of visualization technology previously. At the beginning of this course, we have used the virtual machines using the VMware, right? And also we discussed about OpenOiler is one of the operating systems that's based on visualization designed by Huawei. So one of all these are based on visualization technology. Then we have to have a very good grasp of the basic principles of mainstream visualization technology at the end of this chapter. So the content of the chapter is divided into visualization and mainstream visualization technologies. So we will take the first section on visualization first. What is visualization? Well, visualization has a range of meanings, meaning that we have different meanings to it. But anytime you abstract resources from one form into another, that is called visualization. So basically, anytime that you try to abstract resources and share them, okay, from one form into another, then that means that visualization has taken place. The creation of a logical representation of resources also refers to as visualization. So some resources you can logically represent them, okay, and then you can use them in their logical form, like creating a VM. A VM is basically a logical PC, okay, so this is also called visualization. Visualization is an abstract layer that removes the tight coupling between physical hardware and the operating system. In a normal device, operating system is tightly bounded to the physical hardware. okay? But through visualization, we can separate this tight abstraction of operating system coupling itself to the hardware. We can be able to remove that through visualization. So if you look at the first diagram here, you can see that this is a diagram of what we have before visualization. You have a computer, okay? This is the basically the system, okay? In the computer system, you have different components: the storage, okay, the memory, okay, you can have the processor, all this, and of course input output devices. So in it you will have an operating system installed on it, okay? So you have an operating system, OS, and then after the operating system you can now have your applications like Microsoft Word, okay, you can have Excel, you can have PowerPoint, PPT. So you can have all these installed on the operating system. So that's how a normal PC looks like before you apply visualization on it. But the moment you try to apply visualization on it, then it becomes something like this. You have your normal PC hardware, okay, then you will have the visualization layer, okay, and then you will have the hardware's resources or the pool of resources from different pieces together, okay? So you can have the processors, okay, the input output devices, you can have your storage devices, and the memory. You can have all this, okay, which will be shared among the visualized pieces that you are going to create. So for example, this is a virtual machine that you create. The virtual machine will share a portion of the RAM, the processor, okay. Of course, it will share some components related to the storage and of course the input output devices. So then you can have your operating system installed. Okay, so for example, what we did in one of the labs is we created a VM using VMware. Okay, after we created the VM using VMware, we installed Windows operating system on it. In another lab, we created VMware and we installed what? A Linux, Ubuntu on it. So this the other one, okay? So then after that, you can now install other applications, okay?
On Linux.
On the Linux or on the Windows, okay? So basically what we do here is what is called visualization. Wa alaikum salam. Wa alaikum salam. So this is a kind of visualization. Resources are visualized to share resources. So you have a pool of resources and it can be shared. And the operating systems also are coupled from the hardware. So if you look at it, this is the operating system installed. Is basically derived from the hardware here. So you have your operating system installed on the virtual machine that you create before you will simply install other applications. Wa alaikum assalam. So the important concept of visualization, let's look at it once again. This is a physical server before visualization. You have your hardware, okay? Basically your hardware like a PC. And then you install an operating system on it. Let's say Windows. and then you have your applications. Okay. Word, Excel, PowerPoint, sorry. So that's what we have. So the first one, without visualization. You buy your PC, you need to have an operating system. Okay, so you install an operating system, and then you can install applications on it. So that's what's happening. In the second one, it's when you deal with visualization. Basically, you have your PC, hardware, okay? Then you need to have a hypervisor, okay? A hypervisor is also called virtual machine monitor or virtual machine manager, okay? And then you can create a guest virtual machine, create a VM, okay? And then you can create a guest operating system, and then you can install your applications, okay? So basically, you start with a physical machine. That means you have a PC, okay? After you have a PC, let's call it a PC. I want to give each stage a name, okay? So this is, the PC is called the host machine, okay? After you have a host machine, you may need to install what? An operating system. This is called host operating system because you are installing the operating system on the hardware directly, right? So basically, you can have, for example, a Windows. So after that, for a visualized environment, you need to have a hypervisor. You can give me example of one.
What?
Hypervisor.
VMware.
Very good. Give me another one.
VirtualBox.
VirtualBox. Okay, so we have VMware.
There's one named Bara.
Okay. We say VMware and what?
VirtualBox.
VirtualBox. In the other class, we mentioned about OpenEuler. OpenEuler is also a hypervisor designed by Huawei. Okay, so having created this, then we need to have to create a guest operating system. This is what? Sorry, the guest virtual machine first. We create the VM, right? So we create VMware, VM, and then inside the VM, we have to install a guest operating system like Windows, Linux, anyone. So let's assume what we did in the lab, we already have a Windows. So that's the Windows in the operating system directly on the hardware. That's the host operating system. But now we install Ubuntu on it. So basically the Ubuntu is what? Is the guest operating system, okay? So it's the Linux, which is the guest operating system. And then you can go ahead and install any other application that you want to install on it. Okay, then you can have your apps. So that's the complete architecture. You start with a host machine, then host operating system, then a hypervisor will be installed, And then this hypervisor will be used to create virtual machines. Okay, the virtual machine you create, you will have to assign for it hardware resources such as the CPU and the disk. Okay, and then after that you can install your guest operating system like Ubuntu or Linux, and then you can install your applications later on. So basically, this is the complete architecture. Yeah, historically, visualization starts with Power Pro systems back in 93. Okay, and then we start to have emulators in 98. Okay, then VMware Workstation started its works as far back as 1999. Okay, and then in 2004 we have APVs, which Advanced Power Visualization. Okay, that's 2004. In 2005 we have Zen. Zen started their visualization technology also in 2005. 2006, that's when we have the KVM. Wa alaikum assalam. The KVM is kernel-based virtual machine, KVM. And then now we have cabinets. Cabinets are cloud-native visualization technology that are designed purposely for cloud services. So this actually comes in 2015. But after this, we have many other virtual machines that has been developed, or visualization technology that has been developed, as we've mentioned previously in the previous slides. We have the Open Euler, and we have the VMware, we have the Oracle's VirtualBox. Many of them are now available. So visualization can be divided into three. That's what we call full visualization, and that's what we call para visualization. Then the last one is called hardware assisted visualization. Now, before we go into this, you need to know that visualization is possible only to three components of the device, okay, or the physical machine, which is the CPU, the memory, and the input-output device. Okay, this is a question that is normally they ask a lot of this actually. So the CPU, the memory, and the input-output devices are the components that can be visualized. Okay, so any discussion about visualization has to be divided into these three. Okay, so we can look at visualization of the CPU, that's the processor. We can look at the visualization of the memory, and then we can look at the visualization of input-output devices. Okay, so basically, when we talk about full visualization, it implies that the hypervisor or virtual machine monitor, it visualizes the CPU, the memory, and the input-output device without any modification to the guest operating system and the hardware. Without any modification. Now, this is the key. Without any modification. So you simply, after you finish installation of your virtual machine hypervisor, which is probably a VMware or a VirtualBox or an Open Euler, then without any modification, you can go ahead and create your VM and create the guest operating system, and then you install applications, just like what we did in the lab. So this is called full visualization. In a situation whereby when you try to do this, you have to modify the guest operating system. Then this is called para visualization. Now, take note of the keynotes, the key terms actually. So the first sentence remains the same. We are using the virtual machine monitor to visualize the CPU, the memory, the input-output device, okay? However, the guest operating system need to be modified. Okay, so now that means this is what? Para visualization. Para visualization means it's not full visualization. We are only visualizing a component or a little portion of the CPU. Okay, not the complete CPU. Yes. Yes. Exactly. Para visualization, yes. So modification has to take place in the case of para visualization. Okay, so basically it gives sometimes para visualizations provide high performance, but sometimes it has issues related to compatibility because maybe you allocated more memory or more CPU time, okay, portion of the CPU because you have to modify, okay. So that means it may probably affect compatibilities. But if you probably reduce during modification of this operating system, guest operating system, and you reduce time, I mean space, and the portion of the CPU that will be taken, that means it can give you even more uh, performance. Yes. So then the last one is called hardware assisted visualization. Now, hardware assisted visualization is exactly what we call full visualization without modification of the operating system. However, we can only do this in the case of hardware is assisted when we have to basically bring in another hardware to help. Okay, so there's a hardware that will help. So efficient full visualization is realized with the help of a hardware. So we need to add additional hardware, okay, to be able to achieve this. So there's an hardware that basically is used to assist in this. So the main difference is here is that for full visualization, you can visualize the CPU, the memory, and the input-output device without modification of the guest operating system. But in the case of para visualization, you can as well achieve CPU visualization, memory visualization, input-output device visualization, but then you have to modify the guest operating system to achieve that. Last but not the least, you can achieve full visualization with the aid of additional hardware, okay? And this is called hardware assisted visualization, okay? Modification of the guest operating system is not required also in the hardware assisted visualization. So now let's look at the characteristics of visualization. What are the characteristics of visualization? The characteristics of visualization, I enjoy sitting down because I was alone with Umran before, but now I have to stand up to see your faces. Okay, so what are the things we can do with hypervisors and virtual machine monitors like VMware? Okay, like virtual bots. Okay, so number one, we can achieve partitioning with it. You have a single hard disk and you want to partition it into different virtual machines and still utilize it. Maybe it's 2 tera, okay, and you assign maybe 20 gig to each virtual machine. You can create 5 with this and you can still run your activities. This is called partitioning, okay. You create one virtual machine, assign a portion of the memory, the portion of the CPU, and the portion of the input-output device. Okay, you create another one. You create another one. In the first one, you can be running a different operating system from the second one. Okay, so you can have basically this is your complete system. Okay, and you can have VM1, VM2, and VM3, and VM4. And you can assign a portion of these visualized components, the CPU, the memory, and the input-output device to each one. And you can be able to run all of them independently. So basically, you can run them concurrently and simultaneously. Okay? And in a cloud environment, you can have even multiple users creating different virtual machines, okay, on the server, and they are all using it concurrently at the same time.
At the same time.
Yes. Actually, that's what we do. Okay, so when you create an account, a virtual machine has been created for you. So you will be running everything. If you create an account on any cloud service, for example, like OneDrive, Google Drive, okay? So a virtual machine has been created and assigned to you on the cloud server, okay? So all activities you do is basically within your visualized cloud machine that you're using, okay? So now, the second function of visualization is isolation. These virtual machines that you have created, multiple of them on the same hardware, they are actually isolated from each other. Okay? They cannot in any way overlap. Okay? What it means is that if the virtual machine number one crashed, it cannot affect the second one. Okay? If you decide to delete the virtual machine, the others will be running. Okay, that's what is called isolation. So basically, the virtual machines running on the same physical machine server are isolated from each other. So if you decide to delete this, or this first one get crashed, this remaining ones still work. They are not affected in any way because what? They are isolated. That's the meaning. Isolation means that each one is independent of the other one. They cannot basically overlap with each other. So that's the second function or characteristics of a virtual machine. The third one is called encapsulation. Encapsulation is exactly what I used to do when I used to teach a course on network operating system, NOS, before I used to teach this course. And I found out that students struggle to create and configure basic directories. Okay, what do we call it? Active directories. Okay, so what I will do is from home, I will create virtual machine. I will create Active Directory and give basic configuration of this virtual machine. Okay. After I finish the configuration, I will encapsulate it. After I encapsulate it, I will save the encapsulated file into a flash drive. So if I come to the class, I will share this flash drive to the student. I will be copied. If they start the virtual machine, okay, they will see the virtual machine with the basic configurations that I have done. So if they are going to follow the lab, it will be easy for them to follow the lab because the Active Directory is created and the basic configurations has been done. So maybe they just need to follow the remaining ones. Okay. Now, it implies that encapsulation is a situation whereby you can actually encapsulate a whole VM. For example, if you want to encapsulate this, it will be converted into a single file. Okay? And then you can copy this file. If you can copy this file, you can move it to any machine. just like what I explained to you, okay? So you can move the file into any machine, and any machine that you put it, it will go together with all the content and configurations that you have done. Exactly. You understand? So that's what is called encapsulation, yes. Then last but not least is hardware independence. Now, because I created this encapsulated file on my machine, which is quite different from the one in the lab in terms of the memory, in terms of the CPU, and probably the space, hardware space needs, okay, storage space. It means that if I move it to another machine that has a different configuration, I should not have any issue. This is what is called hardware independence. It did not depend on the hardware. Okay? If it depends on the hardware, it means that the lab machines that I'm going to transfer my encapsulated file into must have the same type of configuration and specification with my device. Do you understand? And also, if there is some installation I have made here, they has to be the same. Otherwise, it will not work. But that's not how encapsulation works. Because hardware independence is part of the characteristics of a visualized environment, it doesn't matter. Any type of device I move it to, it will work. Just like any type of device that you open the iCloud, okay, or the virtual box, it will work. Why? Because it's hardware independent. Doesn't matter. It can work on any hardware. Yes. So that's the meaning. So if you move, you can see here, you can move file from one machine to another, and from another machine, you move it back. It will all work because it doesn't depend on the hardware, okay? So VMs can run on any server, no modifications are needed. If there is hardware dependencies, it's either if you copy it, you'll find out the virtual machine will not work. And then maybe you have to start doing a lot of modifications before it starts working. That means that it's not compatible. Okay? But virtual machines or visualization gives hardware independence. So basically it can work on any machine. It doesn't matter, irrespective of the type of machine that you have. The advantages of visualization. On a physical server, you have the CPU, the memory, and the input-output devices, and you have your operating system installed on it, and you have your applications, right? And then you have your applications. This is in a physical server, but in a visualized environment, we have the physical server with these properties or components, CPU, memory, and input-output devices, okay? And you have your visualization hypervisor that gives you virtual machine monitoring, okay? And then you can create your virtual machine in which you can have a guest operating system and you have your application. Also, this you can have a guest operating system. Maybe you have Windows in this one, and then here you have Linux. It doesn't matter, okay? And then you can have your application. So basically, this is in a visualized server. Now, we have to look at visualization of these components one after the other. What are the components? The CPU, the memory, and the input-output. Okay? The CPU, the memory, and the input-output. So now, let's look at for CPU. For CPU, without visualization, Without visualization, you have your hardware CPU. Let's say a CPU with x86 architecture, and then you can simply install an operating system kernel, and then you can have your application. This is what we explain. When you have your PC, this is what you do, okay? The second one is full visualization. For full visualization, you have your CPU, you have a VMware, for example, you have a guest operating system created, okay, and then you have your applications. If you have to take details into account, it means that after the CPU, okay, and the VM virtual machine monitor or hypervisor is created, okay, you have to create, of course, a VM virtual machine before you install the guest operating system on it, okay, and then you can have your applications. So this is the user instructions, and from here basically is the work of emulators. Emulators are the hypervisor, the VMware that we have mentioned basically. So for assisted hardware assisted visualization, the architecture here is the same, okay, except that no root mode is needed, okay, at the level of the guest operating system, and at the level of virtual machine monitor, you may need to have what is called a root mode, because another hardware will be installed to assist in creating these virtual machines without modifications to the guest operating system. And then you can have your application. So that's how it works. This gives the full visualization of the CPU. So this first one without visualization, this one, second one is full visualization. Number 3 is hardware assisted visualization. But then what happened is that you have the CPU now, okay? The CPU in a virtual machine is called vCPU, virtual CPU, okay? So this is basically your normal CPU, but then you need to create a virtual CPU. So what happened is that from your normal CPU, there's what we call a physical kernel. So you have to create physical kernels, a multiple of them, depending on how many virtual machines you are creating, okay? Then a super thread is used to create the virtual CPU. So the virtual CPU is created through what is called a super thread from a physical kernel. A kernel is basically the core of the operating system. So basically it helps to visualize the CPU and create a super thread from it. In return, a virtual CPU is created. So this virtual CPU is the CPU on the virtual machine. Okay, so this is the CPU on the VM. That's why it's called vCPU, virtual CPU. So that's done with the first one. The first one is what? The CPU. So now we discuss the memory, how visualization takes place on the memory. Okay? So in the case of memory, you have, for example, a memory. This is the physical memory. Okay? So this is on the host machine. That's why it's called host physical address. And this is called HPA. Now, what is a physical address? A physical address, okay, is the address of the sector that contains required information. So sectors on the memory, okay, are given what? Addresses. Okay, so if you have your physical memory, it will have different sectors and clusters in them. And each sector and cluster contains information, right? But then to be able to point at this, it must be given what? An address. And that's what is called host physical address. The address directly on the what? On the host memory. Okay, so now look at this. This is the memory. You can see that this memory is divided into different sectors. Okay, maybe this is, I don't know, it continues like this. Okay, so now to be able to visualize this carefully, we need to create what is called guest physical address. After we create a guest machine or guest operating system, okay, of course, before you create a guest operating system, you must have created a virtual machine, right? So on this, for example, this is the first virtual machine, VM1, and another VM is the second virtual machine, okay? So now we are looking at the VM. Now, look at this. This one is the what? It's actually the physical machine, PM. That's why we call this host physical address. So this is the physical machine. Now you created a virtual machine 1 and 2. Okay. So in the virtual machine, you need to have, it will create what is called guest physical address, which is called GPA. So it means a portion of this sector, okay, that was used, that is to be used by this machine, will also have to be sectored into different addresses. So you can see 1, 2, 3, 4, right? Let's say this is 1 portion, 2, 3, 4, 5. So the whole of this is only this portion. Do you see it? So basically, it means that maybe this is 20 gig. Okay, so it means that the 20 gig will be divided into these different addresses, and that will be called GPA. And each GPA so you can have different GVAs, guest virtual addresses. So in other words, from a physical machine which uses host physical address, GPA, you have to create this is HPA, okay? You have to, it will create for you GPAs. From GPAs, it creates for you GVA. So, and this is the addresses of the host virtual addresses, okay, that will be used by the operating system that is to be installed, or the guest operating system that is to be installed on the virtual machine V2. Now, the same also happens here for V1, okay? You can see that the memory is shared from host physical address of the physical machine, okay, and then it's being shared also further into GVAs from guest physical addresses. So this is very common in KVMs. Okay. For the avoidance of doubt, the KVM is another hypervisor also. Okay, just like virtual machine, virtual box. Okay, just like VMware. So we have also KVM. So this is how it's basically divided into multiple memories and then share it. So we go to number 3. Input output. Because we said visualization is into 3: CPU visualization, memory visualization, and input output visualization. So this is the third one: input output visualization. Visualization of input output devices refers to visualization of devices that are designed for input and for output. For example, like the mouse, right? Like the keyboard. Okay. If you create a virtual machine, the mouse must be able to work in the virtual machine. This is visualization of the mouse, input output. Okay. And you must have a screen for the virtual machine. Okay. For every VM that you create, the keyboard must work on it. Otherwise, you can't do anything. You know. So if you double click on the virtual machine's desktop, then the mouse transfers to the virtual machine, right? So now that's what happened. This happens through what we call emulation. Okay? Emulators. So it uses what is called quick emulators. Okay? Quick emulators also are called KMOS. So from now on, we will just say KMO. If we say KMO, it means quick emulator. The emulator helps basically to visualize input-output devices, the mouse, the keyboard, the screen, anything that has to do with input or with output. Okay, so it's the KMO that helps to do this. So without the KMO, this is not possible. Okay, so we need a KMO to do this, emulators. However, not only KMO, there are other emulators that works, okay, on other visual machines, visualization technology. Okay, KMO is the most commonest one. KMO is the most commonest one, okay? So basically what it means is that hardware visualization can be achieved of input-output devices, okay, can be achieved through emulators. So you can have hardware devices, okay, visualization, and all these, after you create the guest operating system, you may have to use a KMO, okay, in the virtual machines. Then the KMO will help basically to emulate the KMO. The KMO will help basically to create the visualization of the input-output devices. Okay, so KMO is very important. What can we do with a KMO? Is an emulator. Okay, it emulates. It's a software actually. Okay, it's a software. It emulates the devices. So software is used to emulate specific devices. Okay, so in the case of KVM, we can see that a KMO is used. Okay, a KMO is used. So we can see that multiple context switches are required for each input-output device. Okay, it starts with the virtual machine, then you have the hypervisor, then you have the camo, okay, and then the camo together with the hypervisor basically, okay, and then it will be able to emulate these input output devices. So for example, you have any input output device, for example here, okay, so you need a driver, okay, you need an emulator also, okay, and then the device model will be emulated, okay, and then we need a native driver for input output device, and then you can have your applications. So here basically is the hypervisor like VMware or VirtualBox or OpenEuler, anyone, okay. So basically it helps to emulate the input output device for full emulation of the device. There's another one that we call also Visual. Visual is also another device or tool that can be used to emulate input output devices, okay. So it's specialized device drivers including the front end drivers, and also is efficient in communication between front end and back end drivers, and in addition it reduces transmission overhead between virtual machines and hosts. It can also share memory, and it can do what is called batch input output device, and it can do what is called synchronization of event notification mechanisms. So basically these are all what Visual can do for you when it is used to emulate input output devices. However, the diagram did not really change significantly, except that we can have now what is called hypercore, okay, and then we can have the shared memory, okay, between the back end and the front end, the back end and the front end. So that's all about the visualization of CPU, memory, and input output device. Any question? I didn't come with my water today. By the way, the midterm exams are already on the blackboards.
We see.
You find it?
Yes.
Very good.
Not very good.
Not good?
Not good. It was very hard for some exam.
It's very easy.
Not easy.
I told you just go and read the questions on the Huawei portal. I will ask the same questions, and that's what I did.
Father told me, but I said no, I don't think so.
And the same will happen also in the finals.
Oh, it's fine, inshallah, for now.
But then before you can pass the finals, you need to try all the questions at the end of the Huawei, the completion.
Of the chapter.
Yes, not you have to do for the chapter, and you go to the last one and also answer it.
The last one
Okay,
comes up.
course completion.
How much we have time to do it? Only one time?
You have
Three
3
times.
times. You did already?
Yes.
Did you pass?
First time, no.
But you passed now?
Yes.
So do you have the certificate? If you pass, they will give you certificate. Yeah, your certificate should be there on the portal. Let me show.
They want to pass.
No. You need the certificate, because if you get the certificate, I will give you a special grade for it.
Now I have that.
Okay. Let me show you. This is how the certificate look like. By the way, I will share with you guys all the questions and all the answers.
So we can study
For the final exams, for the Huawei. Yeah, these are all. I try to compile them after I pass my own. Okay. For sure, I will share with you. For sure, I will share with you. So this is. Sorry, I forgot. I'm recording. So don't worry, I will share with you everything. Okay. I want everybody must have this certificate before you finish this course. Inshallah. Almost finished. This chapter 6. You did chapter 5 on the. It's 12 chapters only. It's and the remaining ones are short. Yeah. Omran, try to log in. I will find your certificate for you. So let's go to the last part. Now we have less than 10 slides to finish. The last part basically talks about the mainstream visualization technologies. The mainstream visualization technologies, basically we already have an idea of them. The VMware, the VirtualBox, the KVM, the OpenOILab, the Zen Cloud, all these are the main visualizations that we have. So just this section, we will just explain few of them, not all of them. First one, Zen visualization. Mostly it's called Zen Cloud. Okay. This one is also another hypervisor, virtual machine monitor. Okay. So it's a hypervisor. Let me get back my mouse. It's a hypervisor. Zen is a hypervisor, and is the first program that is loaded after a server. Okay. After a server is enabled through the BIOS. So once you boot your system and uh, the BIOS is loaded, so basically the Zen Cloud will be loaded into the BIOS. Okay. Then a VM, a virtual machine with a specific permission is enabled, and it is now called DOM0. So now in Zen Cloud, instead of calling them VMs, they are called what? DOMs. So you can have DOM0, DOM1, DOM2, DOM3. It's the same thing as what we have in VMware as well. Virtual machine 1, virtual machine 2, virtual machine 3. Okay? So it's just a change of name. Okay? So also, the operating system of a DOM can be either a Linux or a Unix. Okay, so you can have DOM1, okay, which is basically a VM, DOM2, which is another VM, okay. In it, you can have an Ubuntu and a Kali, for example, okay. So DOM0 controls and manages the hypervisor. So basically, DOM0, this is DOM0, which loads into the BIOS immediately with a specific enabled permission. It's the one that controls the whole hypervisor, which is the Zen. Okay, so you have your hardware and you have your Zen operating system. Sorry, not operating system, the Zen hypervisor. Okay, in it, it will create automatically DOM1, and then you can create other virtual machines by yourself. You can control the Zen cloud using the DOM0 hypervisor that is, virtual machine that is being created. So basically, this question is asked a lot. What is the function of a DOM0 in XenCloud? It's for management of the operating systems. Okay, so basically it's used to manage the operating system. So you can see that DOM0, you will see it's written management of Linux or Unix kernel. Okay, they ask a lot of these questions actually. So basically it's used for the management of the operating system. So after the XenCloud, another main technology in visualization is the KVM. The full meaning of KVM is kernel-based virtual machine, because it operates from the kernel of the operating system, right? So that's why it's called kernel-based. And the essence of the KVM is kvm.ko, which is a visualized mode in the Linux. Okay, it uses Linux to perform operations such as task scheduling, memory management, interaction with hardware devices. So actually scheduling is done by what? The CPU, right? Now you have to remember Dr. Tahani's class, scheduling, right? You can have different types of scheduling. Operating system, of course.
Yes, yes.
Right? You have different types of scheduling. First come, first serve, last job stuff. Okay, all these are what? By what? The CPU. Now the second one is the memory. And the last one is what? The input output. So you have the three that we mentioned. Hardware devices, okay? So KVM is open source. Okay, it's an open source software. Okay, and it's integrated with Linux 2.6.20 kernel as far back as February 2007, sorry. And KVM, you can create virtual machines with it, okay, using a Linux operating system as the guest operating system and processes scheduled by the CPU, basically. So a KVM runs in the kernel space. That's why it's called kernel-based, because it operates from the kernel space. Now, if you remember, in operating system, there are two spaces in operating system: the user space and the kernel space. Right? The user space and the kernel space. So in the kernel space, that's where you have your KVM. And we already mentioned previously, it uses an emulator that is called a KEMO. A KEMO means quick emulator. Okay, quick emulator is the emulator that is used to emulate input-output devices. The mouse, the keyboard, the screen, all is done by the KEMO. So this is how it looks like if you put the architecture of a KVM with a KEMO. So basically you have your hardware and you have your kernel, the kernel of the operating system in it, because it operates from the kernel, of course. You will see from the kernel, you will see the KVM, okay? And then you can have the KEMO, and then you can have the virtual machine. Very easy architecture. And of course, after that, you can have host processes running, okay, or basically applications running on it, okay. So things that the KEMO can be able to emulate also include, in a KVM, includes CPU, memory, input-output devices, USB, and a NIC, network interface card. The working principles of a KVM, okay. So basically, because it operates, yeah, I just mentioned to you now that we have a Linux operating system, we have the user space and the kernel space. So these are the two spaces if you put them in the architecture. So from the kernel space, you can have your KVM because it operates from the kernel. Okay, and of course you will see the different directories, main directories of the KVM. Okay, so you have KVM VM FD and KVM vCPU FD. So these are basically this for the virtual machine, and this is for the virtual CPU. Okay, this for development, and then you can have this interacting with the other space of the user space, and the KMO is within the user space. Okay, so the KMO interact with the kernel mode, and you can have the user mode also in the guest operating system or in the guest virtual machine. So this is what we have here. So you can see that the KVM is a module of the Linux kernel, and it runs in the kernel space. It's obvious from this diagram that the KVM is running from the what? The kernel mode or kernel space. Then the KMO is running in user space. So you can see that this is the KMO and it's running from the user space. Okay, it's running from the user space. It's used to visualize input output devices. Yeah, that's what we said about the KMO, quick emulators. We need emulators to be able to manage input output devices and visualize them correctly. Okay, and after the KVM mod is installed in Linux, there are three mods, which are guest mode, user mode, and then the kernel mode. So then it becomes 3 mods. So you can now have guest mode 1, user mode 2, and what? The kernel mode 3. So this is only possible after you install the KVM. If before you install the KVM, Linux have only 2 modes, user mode and kernel mode. But if you install the KVM, it will create for you additional mode, which is called guest mode. So you can have 1, 2, 3. Visualization platforms management tool, we have what is called LeafVert. This is another management tool, okay, for visualization platforms. LeafVert is a set of APIs developed in C language, basically. It aims to provide a universal and stable software layer to manage multiple visualization methods on the physical machine and also on the virtual machine. And it also supports remote management. So basically, it's a tool. The LeafVert is a tool, okay? Or I can simply say a software. It has a multiple number of APIs which are designed in C language, okay? And LeafVert is a visualization library. It's a more or less like a library, okay? That's why it's called LeafVert library, a Linux operating system, and it's also an open source project, okay? And this tool can be used in KVM, Zen, VMware, and Hyper-V. Yeah, Hyper-V is another hypervisor actually. We didn't mention all true, and it's very popular actually. Okay, so we have Hyper-V also. So basically, LeafVert, you can see that the library of the LeafVert, you can install it immediately after the hypervisor. If you have a Zen or a KVM, you can install it, and then you can create other tools basically to view management tools. So it helps actually to manage a lot of virtual machines that you are going to create, and it's a library with reference APIs that can help in managing all these virtual machines that you are going to create. So if you put Zen Clouds and KVM together, you can see the difference easily. The Zen is installed directly on the hardware, Okay, and it creates virtual machines that are called DOM, starting with a DOM 0. DOM 0 basically is enabled by default and is a DOM that basically is used to manage what? To manage the other operating system, okay, the Linux operating system, and also to manage the Zen cloud. Okay, so you can create many DOMs, which are called DOM U's. Okay, if you look at the other one, KVM, KVM is installed directly in the Linux operating system, okay, in the kernel mode of the Linux operating system, and it's being managed using KEMO, Quick Emulator, and then you can create your guest operating system in the KEMO using the KEMO, okay, and then you can have your applications on the operating system Linux. So this is how it's done. Basically, this is called type 1 virtual machine, and this is mostly called type 2 virtual machine, where the hypervisor and the operating system, the guest, not, this is not the guest operating system, this is host operating system, are residing in the same place basically, and interacting directly to the hardware. So that's all about this chapter. If you have any question, let's try it. Any question? So let's look at this question. In full visualization, virtual machine monitor is used for CPU, memory visualization, and guest operating system is used for input-output visualization. The guest operating systems need to be modified to coordinate with the virtual machine. This method provides high performance but poor compatibility. True or false?
False.
Why did you say it's false?
Is data virtualization. Full virtualization without modifying.
Exactly. So the key word here is modification of the guest operating system. Once the modification of guest operating system takes place, then that means this is what? Para. But if we didn't mention, if we say that no modification of guest operating system, it means it's full. So basically false, right? We cancel this. LeafVat, which is software that is used as an API, right? It carries APIs, is designed in C++. We just mentioned it now, okay? And it can be used in both Zen Cloud and also in KVMs. Okay, so let's look at what they are asking. LeafVat is a visualization library on Linux. Yeah, that's true. It aims to provide a universal and stable software layer to manage multiple visualization modes and virtual machines on physical machines and support remote management. True or false?
Oh.
This should be true. That's the first thing that we mentioned actually. LeafVat is a set of APIs developed. It's a universal and stable software layer that manages multiple visualization methods on physical machines, on virtual machines, and it supports remote management. So basically, they just took this sentence from here to here, and then they brought it back. So this question is true. So that brings us to the end of this chapter. If you have any question, feel free to ask.